some introductions. So the original function is called y equals to fx. Well, fx can be anything. Fx can be x squared, can be x cubed, can be square root x. Undergoes some transformation and becomes y dash equals to fx dash. So y dash and x dash is used for describe new function. Okay, that means new. Okay, the dash means new, which is called the resultant function. So as a result of the transformation, we have this function here. There are 3 types of transformation only, like linear transformation. There will be more like advanced ways of transform it, but like we just learned 3. So translation, dilation, and reflection. We follow the DRT order. Okay, we follow the DRT order. DRT order is when you describe things, you better describe in the dilation, reflection, and translation way. I'll show you. You can describe in other ways. It's not something like you must do this way. It's like it's easier for markers, and also it's easier for yourself to always remember one way to do it. But I'll show you other ways. You can do RDT order or TRD order, but it's different. Okay, it's different. Like the order of describing translation, dilation, and reflection is very important. Just remember that it's very important. It's not really that important for dilation and reflection, but the translation, whether the translation happened before the dilation or the translation happened after the dilation, is very important. That's when you describe it. You need to be careful with that. Also be careful. The question it gives you, like for example, they give you, okay, this is the original function and give you some transformation. They are not in the DRT order, okay? They can describe in any order. But like it's when you describe, for example, you get fx, you have fx, you have fx dash. So ask you what's happening in between those 2 graphs. You better describe it in the DRT order. But the question they ask you, they give you the language they give you is not in the DRT order. So you need to be careful with that. The order is very important. So number 4, the basic shape of the graph after transformation will not change. So what that means, hyperbola graph are not going to under transformation become a truncus graph. Okay, the shape has changed. So you follow the same shape, which means after the transformation is still the same type of question. Okay, that's still the same question. It's still exactly the same thing. So only exception will be the sine and cosine graph. Well, you know sine and cosine graph, they look almost identical, right? Cosine graph is transferred to the left-hand side by pi over 2 units. They can transfer between each other. Okay, only sine graph and cosine graph can be transferred and become each other. That's the only exception. Like exponential graph are not going to under transformation become a logarithm graph. Okay, that's not going to be achieved by transformation. Number 5 is, I want to say, mapping is the best method I find to deal with transformation. That's the easiest method. It seems like going to become really complex, but that is actually the easiest way to do it. I can 100% sure you can get that question right if you know the method and use it correctly. So the first one we introduce is translation. Translation is describe horizontal or vertical movement. Okay. Another thing I want to say is I don't use transformation to sketch graph. Okay, so if you learn Spech, there's only one exceptional thing, which is like sketch the inverse sine cosine inverse functions, but that's the only thing. But if you're not learning Spech, I'm not using transformation to sketch graph at all. So like I know there's some method like teach you like okay, this is the basic truncus graph. You see the +2, which just means move to the left by 2 units. So therefore I'm not using that method. Okay, if you ever see like I'm sketching a graph, I will always look at the key features. So okay, because x +2 is the denominator, that equals to 0 is not going to be achieved. So x equals to -2 will be the asymptotes. That's how I find asymptotes. I'm not using transformation to see the change of the graph. Okay, so I will teach you exponential and logarithm. You can see what method I use at that time. So transformation is just transformation. Okay, you don't know transformation, you can still draw good graphs. So that's one thing I want to say. Trying to use other method to sketch graph. Describing horizontal and vertical movement. So translate. Okay, the language is important as well. Like there will be some question ask you to describe things like what's happening in between 2 graphs. So you need to know exactly what language you need to use. So translate A units to the right, or translate A units in the positive direction of x-axis. So you can choose both, okay? You can choose both, either the front one or the second one. So let's see, we have a graph, like a quadratic graph, that's 0, 0. I would say translate A units to the right. You know the graph will look like this. Okay, you know the graph will look like this. So this turning point will become A0. Let's translate A units to the right. So in this graph, we have xy. In this graph, we have x dash and y dash. X dash, y dash is the new point. So let's compare the same point. The same point is the turning point. Okay, the turning point and to the turning point, they are the same point. So on the original graph, you have x value of 0. On the second graph, you have x dash value of a. So therefore, you can see x dash will equals to x plus a. That's how you express what's the relationship between the new point and old point. So this equation means the new point equals to the old point plus a. Okay, the new point equals to old point plus a. So by using the language they give you, so you can write the equation in x dash to be the subject in terms of x. So new x equals to old x plus a. Similarly, if we translate a units to the left, what we should write is x dash equals to the original x minus a. Y is not going to change because we're not moving vertically yet. So if you translate b units up, so this point translate b units up, you will have the same x value but different y value. So the new y value will equals to the old y value plus b. Okay, the original y value plus b. So same idea. If you translate b units down, you will have y dash equals to y minus b. Okay, y minus b. So that's what you should write at the beginning. Okay, let's have a look at the question. Okay, I'll do this. Okay, I changed my teaching way. Let's do this first. You can have three things in transformation question. The first one is the original function. Original function. So for original function, you have y equals to fx. Well, y in terms of x. Well, y in some x. Second one, you will have the resultant function. What you have is the y dash equals to some x dash. Well, some x dash. Number three is transformation description. Well, describe how it has been transferred. Or a matrix. Okay, a matrix is the same as the language. Okay, or a matrix. Okay, so what's the transformation language will tells you. This can help you to write the equation x dash in terms of x and y dash in terms of y. By using this description, you can find the equation like the new x equals to how many old x, the new y equals to how many of the old y, or old y doing what. And matrix are the same, like give you the same thing. Matrix are going to give you the same thing, which is easy actually for matrix. Okay, so this is from number 3 what you should get. So in other words, if I have x dash equals to some x, y dash equals to some y, I can write the description as well. Okay, I can write the description. For example, it gives you x dash equals to x plus 4. You know that's translate 4 units to the right. Okay, it can go both ways. It can go both ways. Okay, so there are only 3 types of the question. Okay, what's the 3 type of question? You can hide one thing and given the other 2, ask for the third one. Okay, for example, give you number 2 and number 3, give you the resultant function and give you the transformation. It will ask you what the original function will be. Okay, or give you the original function, give you the resultant function, ask you what the transformation will be in between them. Or give you the original, give you the transformation, ask you what the resultant function will be. Okay, there's only 3 types of the questions for the whole transformation topic. Only 3 types. So that's hide first one, second one, third one. Give you the other 2 and ask for the third. So let's have a look at examples here. Every type, each type got their own way to do it. So the first one, find the rule for the image. Okay, find the rule for the image is asking for y dash equals to some x dash. Okay, it's asking you that. Asking you the resultant. Asking you the new function. The image of the graph of y equals to 1 over x. That's the original. You have the xy function. Okay, xy function. That's the original. And a translation of 2 units in the positive and a unit in the negative direction of y-axis. This is the description. Okay, so it's asking you number 2, give you number 1 and number 3. So if you have the language, the first thing you do is write out the equation. You can't do math with words. Like, you must change that into a math equation. So what you do is, and the translation of 2 units in the positive direction of x-axis, that's x dash equals to the old x plus 2, without thinking. Okay, that's it. And 1 unit in the negative direction of y-axis, y dash equals to y minus 1. I know most of you can do this directly, give me the answer, but like, I want to go through the method, which when we do harder questions, you know what to do. Okay, that's the first thing you do when you see the word. You change that into the x dash y dash function. That's what you can have from the description. Now let's have a think what you have and what you want to achieve. You want to achieve x dash y dash. What you have is xy. Okay, I have x and y. I want x dash and y dash. Therefore, what I have now is x dash y dash is not working because what I have is xy. Therefore, I will make x to be the subject. X equals to x dash minus 2 and y equals to y dash plus 1. I have xy, so I want to see what x and y is in terms of x dash and y dash. So it depends on what I have. I will make the thing I have into into the other thing what I want. So now I have x equals to 1 over x. I will substitute that in. I will replace xy in terms of x dash y dash. So y equals to y dash plus 1 and x equals to x dash minus 2. That's what I have. So y dash equals to 1 over x dash minus 2 and then minus 1. Well, I can get rid of the dash. That's the resultant function. Okay, that's the resultant function. They are actually with the dash, but I just get rid of it in the end. So that's the method of mapping. Okay, you see what's the relationship between the before and after function and then deal with it. Let's have a look at the second one. Find the rule for the image. Okay, still find the rule for the image. Still asking for x dash y dash. Okay, asking for x dash y dash. You have y equals to this. This is the original. And the translation of 3 units in the negative direction of x-axis. So x dash equals to x minus 3. 2 units in the negative direction of y-axis. Y dash equals to y minus 2. I want x dash y dash. I have x and y now. So again, still, we will make x to be the subject. Okay, what I have, I will make that to be the subject. And sub into the original function. Okay, replace that y into y dash. That's how you achieve the new function. Okay, I replace that y. I have replaced that x. Okay, everything else keep the same. So y dash equals to x dash plus 4 squared minus 4. So y equals to x plus 4 squared minus 4. That's the resultant function. That's the first type. Okay, that's the first type. Give you the original one, give you the transformation, ask you what's the resultant function. So the way we do this is First of all, write x dash y dash in terms of xy according to the language. And then we change xy to be the subject because we have x and y. Because we want to replace xy into x dash and y dash to achieve the new function. Okay, so that's the first type of transformation question. Okay, if we can go to the next page. Let's have a look at the second one. That's the first type. Okay, let's look at the second type. Describe the transformation. Transfer this to this. Okay, this to this. So which one is the new function? First one, second one. Second one. If second one is the new function, we need to distinguish between them. So we make dash there. Okay, we give it like different variable. So I make x dash and y dash. Okay, now I'll write down those two equations here. Okay, now my next question is, okay, for this type of question, give me the original, give me the result and ask me for description. Okay, so this is a little bit tricky. Let's have a think. It's hard for me to explain. Like every year I feel like really hard to explain this. But let's have a think. What type of function is this? What root is that? Square root. Okay, this is a square root function. So square root function is a square root something. Okay, so this is my rule. My rule is square root. So what I will keep is only the square root on right hand side. Everything else to the left hand side. Okay, everything else to the left hand side. So including any coefficient in front, any constant you add or subtract. So what I'll do is y minus 2 equals to square root x minus 1. Y dash plus 1 equals to square root x dash plus 2. Okay, if it's a square root function, I'll only leave the square root. If it's a square function, I will only leave the bracket square. Well, that should be this. If it's a cubic function, I will only leave the square cubic. Well, if there's a number 2 in front of this cubic, I will divide it to the other side. I purely want to leave the very simple rule on one side. If it's a sine function, I will only leave sine, cosine, tangent, bracket. If it's an exponential function, I will only leave exponential something on right hand side. Well, I can't deal with the top, so that's a whole thing on top. So I can't divide or subtract. But I will only leave exponential. Well, what else? What other function we have? Well, logarithm, I have log something. For truncus or hyperbola, I will only leave 1 over. For a truncus, I will leave 1 over something squared. That's the only thing we want to leave on the right. That's the pure rule. Okay, that's the rule. There's no dilation. There's no dilation. Well, if there's dilation, there's only dilate with the x, but there's no dilation from the y. Everything else deal with y. I'll move to the y side. Okay. What else? What other function we have learned? Square root, cube root, square, polynomials. Well, that's pretty much what we know. All the functions we know. Let's have a look at this. After I do this, I will equalize both sides. Because remember, before we substitute something in, and we get like x into x dash, y into y dash. Now I want to equalize both sides. Okay, what I want to achieve in the end is the description. Okay, what I want to achieve in the end is the description. So what you will get, let's think backwards. If I know the description, what I can write? I can write x dash equals to sum x, y dash equals to sum y, right? So if I have description, I will have that. If I have that, I can have my description as well. So it's both ways. So therefore, I will make y dash and x dash to be the subject. Okay, I will make x dash y dash to be the subject. So therefore, I can see the description is translate 3 units down and 3 units to the left, or you can say in the both negative direction for x-axis and y-axis. Okay, this is my thinking step. I want to achieve what in the end? So I can think backwards. If I have that, what I can write. Okay, therefore telling us what we should have. Okay, what we should have. Any questions so far? That's the second type already. Okay, that's the second type. I think in my notes I don't really include the third type in. I can just make one question for you later, and then we can have to think about the third type. Let's have a look at the exercise 2b. So this is a special one. I can't specify what rule is that. Okay, just give me fx, but that's the easiest one. That's the easiest one. So a simple one is f bracket x. I just leave f bracket x. I don't know what is it, but that's something. Whether sine, cosine, I don't care. It's just f bracket x. Okay, f bracket x. I just leave that on the right hand side. So what I have is describe the transformation that transfer y equals to fx to y dash equals to f x dash minus 3 plus 2. So therefore, I only want to leave fx on the right hand side. I'll move the 2 to the other side. So what I will have is y equals to y dash minus 2, x equals to x dash minus 3. Okay, you find, well, I don't care about the same thing. I want to see what I have inserted into the function. Same as the square root. I have insert x minus 1 into the original. I have insert x dash plus 2 into the resultant function. So they need to be equivalent. So now again, I want the description. I need to make y dash to be the subject, and I need to make x dash to be the subject. Therefore is translate 3 units to the right and 2 units down. Sorry, up, not down. Plus 2 is up. So up. Translate 3 units to the right and 2 units. 2 units to the right and 2 units up. That's the second type. Those 2 types are the main type. Okay, they are the main type. There's a third one. Let's give you the resultant, give you the description, ask for the original. That's actually an easy way to do it. If you can find some space below here, I will just write this out for you. So some function let's say y equals to fx, undergo some translate, let's say translate 2 units up and 1 unit to the right, left, let's say left, to the left, becomes y equals to 1 over x squared. Find the original function. Find the rule of the, oh, I just missed a lot of words. So some function translate 2 units up, 1 unit left, become y equals to 1 over x squared, and find the original function. Okay, that's the question. So that's the third type. Ask you for original, give you the resultant, give you the transformation. Let's have a think what to do. That y equals to 1 over x squared, is that a yx or is a y dash x dash? Y dash and x dash, right? It's a new function. It's x dash and y dash. We need to distinguish that. So we should say y dash equals to 1 over x dash squared. Okay, I'll bracket that to make me look at it. It's easier to look at. So y equals to 1 over x dash, y dash equals to 1 over x dash squared. Now same thing. We have the translation description. I'll just write it out. So y dash equals to y plus 2. X dash equals to x minus 1. Okay, again, from the same description, I can have y dash equals to y plus 2 units up and x dash equals to x minus 1 unit to the left. Now it's different. What I want, like I said, what I have x dash y dash. I want xy. So what I have, I will make that to be the subject. Okay, what I have, I will make that to be the subject. I will replace that to the other like variable to make the thing what I want. So x dash and y dash is already the subject. That's why I say it's an easy question. I don't need to rearrange it. That's already the subject. What I have, I will make that to be the subject. Okay, just remember this. What you have, you make that to be the subject. So x dash y dash is already the subject. So y plus 2 equals to 1 over x dash is x minus 1, and then you square that. Square together. So y equals to 1 over x minus 1, bracket, square minus 2. That's the original question. Read the question carefully, okay? Same as like what I said to the test. Like read the question carefully. Not always the simple equation will be the original. Sometimes they will give you a complex question as the original, give you a simple question as the resultant, and ask you what's the transformation between them. Okay, so you need to recognize what is the original, what is the resultant. So read the question carefully. So that's the third type. You can say that's type 3. Okay, type 2 is a both, and this is type 3. Okay, that's the type 3. So I have gone through all the 3 types with you. That's everything for translation. Well, dilation is the same, but a little bit different. I have gone through the hardest part already. So let's have a look at the next page. So I can show you the same, exactly the same method. The only thing is to change is the mapping notation. So for the translation is adding or subtracting. But for dilation, dilation is a stretch or compress from the horizontal or vertical. Like stretch that way, compress that way, or stretch the graph that way, or compress that way. So there are 3 ways to describe it. You need to know all of this because you can choose one way to use, but the question, you don't know what the question will, just how the question will describe it. So the first one is a dilate by a factor of a from the y-axis, but remember that's change x. From the y-axis, let's have a think. That's the x-axis, that's the y-axis. I'll stretch it this way. Stretch it this way. Have a think. The height is not changing. Only the x value is changing. So it's changing the x. Okay. So from y-axis is changing the x. But very annoying. When you say parallel to x-axis, it still change the x. In the direction of x, it's still changing the x. Okay. You need to know that because you need to know what is changing. So from y-axis is changing the x. In the direction of x-axis, okay, in the direction of x-axis is changing x. Parallel to x-axis is still changing x, okay? It's all stretched by that way. So those 3 ways of describing things is all changing by changing the x. So If you have a dilation by a factor of a from y-axis or parallel to x-axis or in the direction of fx, you can say x dash will equals to a times x. Is the original a times by original x times by a. Okay, original x times by a. B, dilate, okay, from x-axis parallel to y and in the direction of y is all change y. So what you can write is y dash equals to by. Well, whether a is a larger number, greater than 1 or smaller than 1, doesn't matter, you just put it there. Okay, times y, new y equals to old y times by b. Okay, remember a and b are positive. We won't say negative dilation. Okay, we won't say dilate by a -3. Okay, we're not going to say this. It's a positive number. If it's negative, it means there's reflection happening. Okay, there's reflection happening. It's not going to be a dilation. The negative only means reflection. Okay, negative only means reflection. So, well, mirror image by x-axis and y-axis, that's reflection. Really easy. Okay, if you reflect by y, it's changing your x value. Can you think about that? If you reflect by x, it's you're changing your y value. Okay, here to here is changing your y value. If here to here is changing your x value, that's reflect by y-axis is changing x value. Reflect by x-axis is changing the y value. Okay, so same x, different y. So if you say reflect in the y-axis is changing the x. So x, new x dash equals to old x minus. If it's reflect in the x-axis, it's changing the y dash equals to minus y. That's how you write reflection. Okay, that's how you write reflection. Okay, when you know this notation, we have done everything. Okay, we basically done everything for transformation. That's it. So we learn all what we need to learn. Now we just combine things together. Okay, we just combine things together. So let's have a look at the example. Write down the equation of the image obtained when y equals to 1 over x squared is transformed by, okay, 1 and 2. Let's go for 1 first. This is the original. I have, okay, I will directly write this down. I have x and y. What I want is the equation of image. I want x dash y dash. Okay, transformed by a dilation of factor of half from the y-axis. What you can write? What equation you can write? Everyone, what you can write? X dash equals to half x. Okay, thank you. It's changing the x value. Okay, it's changing the x value. From the y-axis is changing the x value. Okay, and the dilation of factor 2 on 3 from the x-axis, what you can write? What you can write? Well, you should actually write that down on your paper. So I have x dash equals to half x. Okay, this one will give me y dash equals to 2 over 3y. Okay, that's how you can write dilation. Same question. I have what? I will make that to be the subject. I have xy. I will make xy to be the subject. I have x equals to 2x dash and y equals to 3 over 2y dash. I have what? I will make what to be the subject. And then do substitution. And then do substitution. I will substitute y by 3 over 2y dash. I will substitute x by 2x dash squared. Don't forget the square. So y dash equals to 2 over 3 times 1 over 4x dash squared. Okay, expand the bracket. 2x squared is 4x squared. So y equals to, well, I can cancel this. That become a 1, that become a 2. So 1 over 6x squared. Okay, that's the resultant function. It's exactly the same as the previous page. Okay, what I have, I'll make that to be the subject. So similarly, we can see number 2, reflection by x-axis and y-axis. So reflect by x-axis, I will have y dash equals to minus y. Reflecting y-axis, I'll have x dash equals to minus x. Okay, you need to know what is changing. If you reflect by x, you will change the y. If you reflect by y, you're going to change the x. What I have, I'll make that to be the subject. So y will be minus y dash and x will be minus x dash. What I have, I will make that to be the subject. So minus y dash equals to 1 over minus x dash bracket squared. That will give me y equals to minus 1x squared. The minus x squared minus x bracket squared become x squared. The negative just go. Do you have any questions? Okay, just show you one last thing. Okay, 2 more examples to go. So show you this. This is a good question to make you think. Okay, I will change this question a little bit. I want you to answer me in 2 ways. The first one is this equation to this equation undergoes a dilation by a factor of what from the x-axis, from the y-axis first. And the second one, I want you to answer dilation by a factor of what from the x-axis. Okay, that's 2 separate questions. Okay, you can only choose one number in each line to tell. It's not like happen both by x and y. It's just how y equals to root 2x undergoes a dilation by factor of what become y equals to root 3x, or how the dilation factor will be is dilate from the x-axis and still make those 2 equations like the first one can be achieved, the second one. So you can dilate by 2 ways. Okay, you can dilate by 2 ways. I want you to have a think about this question. You can at least answer me 1. Okay, you can at least answer me 1, which is the first one. First one is easy to answer. Second one might need a bit thinking. So I have a try. That's type 2 question. Give you 2 functions. You need to distinguish between x, y, x dash, y dash. And the second thing is you only want to leave the rule on right hand side. So in this case, the rule is root. Okay, root. Equalize both sides and see the dilation factor. It's a long and boring lesson for today, but it will be much easier after we pass all this basic thing and go to next 2 exercise, which will become much easier. So you should know y equals to 2x is the original, y dash equals to root 3x dash is the new function. They are in a pretty perfect form already. Only square root. We only have square root. I don't need to move anything. Therefore, I just need to equalize both sides. I just need to equalize both sides. It's pretty good now. Now the question is whether you make x to be the subject or x dash to be the subject. Because I want the description. Okay, I want the description. Therefore, if I have the description, I will have x dash y dash to be the subject. X dash equals to how many x? Y dash equals to how many y? So y dash equals to y. There's nothing happened to the y side. Okay, nothing happened. But x dash equals to 2 over 3x. X dash equals to 2 over 3x. That's what's actually happening. This is a dilation factor by 2 over 3 from the y-axis. It's changing x, you say it's from the y-axis. So the first spot will be 2 over 3. Okay, the first spot can be 2 over 3. Let's have a think about the second one. This is a really important point. Okay, this is a really important point. For the second one, because I want to dilate only from the x-axis, which means I want to change the y value. I don't want to change the x value at all. Okay, I don't want to change the x value at all, which means the coefficient of x is not good. Okay, the coefficient of x is not good, because if there's a coefficient, you definitely change the x. Okay, you definitely change the x. So what you need to do, you need to separate that. Well, you know you can do this. Now my x under the root, square root, is only a single x. There's nothing happened to the x. Okay, there's no coefficient, nothing happened to the x. There's another question for the square, what is called quadratic function as well. Like exactly same question asking, I think in VCA or trial paper, asking you, okay, how I can dilate from x-axis, how I can dilate from the y-axis. Ask you for both ways. So you need to know if you want to change the from the x-axis means you changing y. There's nothing happened to x. I want to make as clear as possible from x. There's no coefficient from x. And now this becomes a coefficient. I don't want coefficient on my right hand side. I want coefficient only on the left hand side. I only want to leave the square root rule with x on one side. So I will have y equals to root 2 equals to root x, and y dash equals to root 3 equals to root x dash. Again, I will equalize both sides. Well, x still the same, so there's nothing happened to the x side, but there will be something happen to the y side. So same, I'll make y dash to be the subject. Y dash equals to root 3 over root 2y times the root 3 on both sides. So y dash equals to root 6 over 2y. Just rationalize it a little bit. Just rationalize that a little bit. Times root 2 on both top and bottom. This is only changing the y value. Can you see that's only changing the y value? There's no dilation at all from the x side. So I can say this is a dilation by root 6 over 2 from the x-axis. Okay, root 6 over 2 from the x-axis. Okay, why I say this is a good question? It makes you think. Think what? Why? Why we have two different values? Okay, why we have two different values? Okay, give you the conclusion directly. if graph A can undergo some dilation to achieve graph B from x-axis, for example, it definitely can be achieved by dilate from the y-axis by another factor to give you the same result. Okay, simply, if you can dilate from the x-axis by a factor 2, it definitely can be dilated from the y-axis by another factor. I don't know what's the factor, I need to figure that out, but that's a good example. I can dilate the first graph by 2/3 from the y-axis to achieve that graph. I can also dilate by a factor of √6/2 from the x-axis to achieve the same graph. So there's always more than one way to do dilation. Okay, there's always more than one way to do dilation. Even like extreme case can be, I can dilate from both axis and y-axis for this graph. Okay, I can dilate from both sides. A little bit from that side and a little bit from that side. I can do the same thing. There's infinitely many ways I can do dilations. Okay, infinitely many ways I can do dilations. Well, think about if I stretch this way. I can stretch this way to cancel it, to get it back. Okay, so I can do both ways. Some question will particularly ask you how I can dilate this from x-axis, how I can dilate this from the y-axis. If that's not specified, you can just do your own way. Okay, either dilate from x or dilate from y. But in some case, in some multiple choice, you must go for a particular way. Okay, you can see the example. I put that in the exercise later. You can see one really bad example, like you must go for that way. Okay, there's no other ways we can do it. Okay, that's one thing. I want for the next page, I'm not going to show you the question, but I want you to change this a little bit. Just cross something with me together. Okay, I don't want the part A, B, and C. I just want that to become one question. Okay, the graph of G is obtained from the graph of function fx equals f squared. Well, fx, you treat fx, well, if fx is on the right hand side, you treat it as a root, but if it's on the left hand side, we just treat it as a y. That's a y, okay? By translate 3 units in the positive direction of x-axis and translate 1 unit in the negative direction of y-axis, and then cross the rest, write down the rule for G. I don't want that. I don't want you to write down the rule for G. Okay, and then cross out until by. Okay, so I want then follow a dilation of factor 2 from the y-axis and the reflection in the x-axis. Okay, write down the rule for hx. I don't have hx. And then again still finish at the by. And then follow a translation of 1 unit in the negative direction of y-axis, and then a dilation of blah blah blah. Write down the rule for G. Okay, write down the rule for G. So everything happened at the same time. Everything happened at the same time. Right, I have 10 minutes. Just quickly go through example 2 with you because I want you to try example 1 before we start next lesson. This is a combination of transformations. Okay, this is still language. Okay, this is still a language. I can write x dash y dash equals to something. I have x dash and y dash equals to something. I can still write out equations. I still need to write equations first, but it's a combination. It's not only happen for dilation or reflection or translation. It's all combined together. And the order is very important. The order is very important. But don't worry, let's just still go step by step. What is the image for this equation? Okay, this is I have xy. Okay, I just want to write this down. I have xy. I want x dash y dash. Okay, I don't really need to write what I want, but I have xy. Okay, follow the following transformation. Translation 2 units in the positive direction of x-axis. Okay, in the positive fraction of x-axis, so I can write x dash equals to x plus 2. Same. Second is dilation by a factor of a half from y-x-axis. Okay, tell me whether it's changing x or changing y. Changing x or changing y? X. If it's changing x, it still happens the same line here. I'm not going to write it separately. What I'll do is I'll keep writing this down. But what's happening first is x plus 2. So I will bracket x plus 2 times 1 over 2. That's the dilation. Okay, that becomes your old x times by half. Alright, your calculation order must be the same as your transformation order. Okay, how do you calculate things? It must be the same as your transformation order. The third one says a reflection in the y-x-axis. Okay, is that changing x or y? Reflection in the y-x-axis, is that changing x or changing y? X. So that times by -1. That's the third thing happened. Number 4, reflect in the x-axis. What is that? Y. So y dash equals to minus y. It's pretty fun, just keep writing things. Number 5, translate 1 units down. Y, so minus 1. Because next, still this happen first and then the minus 1. Okay, so same order as your calculation order. Last one is dilate by a factor of 4 from the x-axis. Y again, right? Y again. So times by 4. Old value times by 4. Now question is, what needs to be the subject? What needs to be the subject, everyone? X and Y, because I have X and Y. So I will make XY to be the subject, which is a lot to do. Well, that's a -half, so it's -2x dash minus 2 equals to x. Well, can you see it? Well, I can go for step by step. So I will times the -2 on both sides equals to x plus 2. So x equals to minus 2x dash minus 2. xy needs to be the subject. For the y side, a quarter y dash equals to minus y minus 1. A quarter y dash plus 1 equals to minus y. Y equals to minus a quarter y dash minus 1. And what you'll do is substitution. So minus a quarter y dash minus 1 equals to bracket minus 2x dash plus 2 minus 2 and then squared. So, well, I can get rid of the dash now. Minus a quarter y minus 1 equals to 2x minus 2x squared. Minus 2x squared. And then minus a quarter y equals to 4x squared plus 1. Y equals to minus 16x squared minus 4. Alright, that's the resulting function. That's very easy to deal with, right? We just keep writing the equation for x dash y dash. Know what we have. We have xy, we make xy to be the subject, substitute into the original function. Rearrange it, get my new function. Okay, so we have done the most difficult part for transformation today, okay? So later on will be much easier compared to this. You have 3 minutes. If you want, please try this question. If you don't want, you can try at home tonight. Get the first question done, okay? Get the first question done. I want to see the resultant function for G. Okay, you can try this now. It's exactly the same as example 2.